Okay, here's part 3 of the notes for section 1.2. We just talked about parallel perpendicular lines, how their slopes are related with the parallel lines. Their slopes are equal. It's supposed to be parallel. For perpendicular lines, they intersect at a right angle, and those slopes are opposite reciprocals. But then, you can also have two lines that intersect, but they don't intersect at a right angle, and this one would be neither. So this is parallel, perpendicular, and these are just two lines that intersect. So they're neither parallel nor perpendicular, they just intersect. Alright, so here what we have to do really is compare slopes when we're talking about parallel and perpendicular lines. So this example, it says, are the pairs of lines parallel, are they perpendicular, or are they neither one? And they're not going to give it to you in a graph. You'll have to do it algebraically. So what you have to do is compare slopes, which we just set up here. So as you can see, these equations are given in general form, so we got to figure out what the slopes are. We have to figure out the slopes of these. That means solve them for y. Alright, this first equation, 3x minus 5y equals 4. Let's solve this for y. So I'm putting 3x on the other side with the 4. I'll deal with this one in a minute. I'll put it over here. Solving this first equation for y, because I'm trying to figure out what the slope is. Alright, if I divide through by -5, I will have -3 over -5, which is a positive 3/5. And then I'll have a positive 4 divided by -5, which comes out to be -4/5. Alright, you can see that this slope, which is what we wanted, coefficient to x on the other side, positive 3/5. Alright, that was that first equation. We found that the slope was 3/5, so we're going to compare it to the slope of this one. Again, let's get that y by itself. So I'm going to move the -6x over by adding 6x. Alright, that was a -6x there. To get it to the right-hand side, I needed to add 6x, so now it's on the right. When I divide through by 10, I'll reduce this in a minute. Yeah, let's reduce both of those so we can see that a little better. Alright, 6 over 10. If we take them both down by 2's, and take this down by 2 also, for this. Man, that comes out to be exactly the same, right? The exact same line. Alright, m equals 3/5. We're just comparing the slopes, so our answer here is parallel. Alright, that symbol right there means two parallel lines. Alright, parallel. You're going to write the word out, parallel. Right, because your answer should either be parallel or perpendicular, or it should be neither one. These slopes are exactly the same, so those are parallel lines. Let's do the same thing down here with part B. See how this one comes out. With part B, yeah, let's do this one. I want to solve this for y. We're comparing slopes here. So I've got -7y is equal to, let's move the 2x, so it'll be -2x on the right with the 13. Then dividing through by a -7, yeah, that's a -13 there, over 7. Alright, so this slope is 2/7. Alright, let's look at that second equation there. I'm solving for y. I'm trying to figure out what those slopes are. -2y, let's move the 7x over to the right, the -7x over with the 21. Now when I divide through by a -2, and if we notice, this slope is 7/2. Okay, so what we are comparing, we're comparing 2/7 with 7/2. Yes, they are reciprocals. That's 2/7, that's 7/2, but these are both positive numbers. Yes, they're reciprocals, but they are not opposite reciprocals. So your answer here is neither one. All right, these are not perpendicular. They're not parallel. They're just two lines, positive slopes, you know, something like that. All right, neither parallel nor perpendicular. Good. All right, I thought I had one more. Yeah, I do. I got it right down here. I just hope I have enough room. I think I do. All right, last one. Write the equation of a line that passes through this point of 5, 7, and it's perpendicular to this given line. All right, perpendicular to that given line. This is going to give an indication as to the slope that we're going to use, because it didn't give us 2 points, can't calculate the slope. We've got to figure out the slope using the fact that it's perpendicular to this line. Let's look at the slope of this given line first of all. Slope is 0.25. 0.25 is 1/4, same thing. 0.25 is 1/4. Alright, that's the slope of the given line. So the slope of the line that we want is perpendicular to that. So a perpendicular slope, this is that little exercise we went through before talking about the opposite reciprocals. The given slope is 1/4, so the opposite is going to be a negative. If I flip over 1/4, I'll get a 4. So those are opposite reciprocals. This is the slope we're going to use, and it passes through this point. So at this point in the problem, you can use point slope form or you can use slope intercept form. Either one. You know I like point slope form, so that's what I'm going to use. I will use the y minus y1 is equal to the perpendicular slope, alright, not the exact slope of this one, but it's perpendicular, negative 4 x minus 5. Just be careful when your slope is negative and you're distributing, that you distribute a negative number. Watch your signs. Alright, that's your answer. And you'd get the exact same thing if you used, again, this point, that slope with the y equals mx plus b. You'll find that b is 27. Then make sure you write your answer this way. Yeah, that was 1.2. There's kind of a lot in 1.2, but these notes should help you get through the homework okay. Similar problems on your test, you can expect that.